Section 4.6 Graphs of tangent function and cotangent functions. Graphs of secant and cosecant functions. Properties of tangent function. The period of tangent function is pi. Tangent function is an odd function, and that is tangent of minus x is minus tangent x. Tangent function is symmetric about the origin. Tangent x has a vertical asymptote at x equal to pi over 2 plus n pi, where n is an integer. Domain of tangent functions are all real numbers except odd multiples of pi over 2. The range is minus infinity to infinity. How to find the graph of y is equal to a times tangent bx minus c. First, find the consecutive vertical asymptotes by solving equation for x. So take the bx minus c is set to minus pi over 2 and bx minus c is set to pi over 2, and we solve for x. And number 2, divide the period into 4 equal parts to get the key points, and then plot the graph for one cycle and then extend the graph 2 addition cycles to the left and to the right. Example 1. Graph of y is equal to tangent x for 3 full cycles. Number 1. The vertical asymptotes are at x equal to minus pi over 2 and at x equal to pi over 2. So then find the period. The period is pi. And divide the period by 4. So you get pi over 4. And that's the increment. So let's find the x values between the vertical asymptotes by adding the increment pi over 4 as follows. So the first point x1 is start with negative pi over 2. To get the second x point, you add pi over 4 to the previous value. So it becomes negative pi over 2 plus pi over 4. So then you basically multiply top and bottom with the 2 and add into pi over 4. So it becomes negative 2 pi over 4 plus pi over 4, which is negative 2 pi plus pi over 4. So it comes out negative pi over 4. To get the third point, you add pi over 4 into the previous point. So it becomes x2 plus pi over 4, which is x2 is negative pi over 4, plus pi over 4 becomes 0. To get the fourth point, you add pi over 4 into 0, so it gives you pi over 4. To get the fifth point, the last point, add pi over 4 into pi over 4, I mean x4. So pi over 4 plus pi over 4 becomes pi over 2. So now this is the table. X values are x1 is negative pi over 2. x2 is negative pi over 4, and x3 is 0, and x4 is pi over 4, and x3 is pi over 2. Then you find the y value, tangent x, so that minus pi over 2 is a vertical asymptote, and that pi over 2 is a vertical asymptote. And tangent negative pi over 4 is negative 1, tangent 0 is 0, and tangent pi over 4 is 1. So now we draw the vertical asymptotes at x equal to minus pi over 2 and x equal to pi over 2. And then we plot the points negative pi over 4 comma negative 1 and point 0 comma 0 and pi over 4 comma 1. And we join the points to a smooth curve and make the curve parallel to the vertical asymptotes. And if we do that, we get this one. So you can see that this is the vertical asymptote. And when it's pi over 4, negative pi over 4, the answer is negative 1. When it's positive pi over 4, the answer is what? 1. So we connect these 2 points like this one similarly. Now we can go and every pi over pi units, we can draw another graph left and right. Use the two now consecutive asymptotes x equal to minus 3 pi over 2 and x3 pi over 2. Draw a similar curve passing through the midpoint x equal to minus pi, and then draw the curve through x equal to pi. Select this one. So that was we drew this from negative pi to pi over 2. So now we draw another pi units from pi over 2. So draw a vertical asymptote, and then draw another vertical asymptote, pi units left side. So it'll be negative 3 pi over 2, and that's the center, and we draw the graph of tangent x. And then at this center, graph another tangent. So now it's a complete graph for 3 cycles. Properties of cotangent function. The period is pi. It's an odd function. Cotangent of minus x is minus cotangent of x. Is symmetric about the origin. Cotangent of 0 is undefined. Vertical tangent, vertical asymptotes at x equal to n pi. Domain is all real numbers except integral multiples of pi. And the range is negative infinity to infinity. Graphing y equals to a cotangent bx minus a. So we graph the cotangent from 0 to pi. So bx minus c equals to 0 and bx minus c equals to pi. So solve for x and then divide the period into 4 equal parts to get the key points. Then plot the graph for one cycle and then extend the graph to 2 additional cycles to the left and right. Example 2. So let's sketch the graph of y equals to cotangent x for one cycle. The vertical asymptotes are at x equals to 0 and x equal to pi. And then find the period. The period is pi minus 0 is equal to pi. And then divide the period by 4 to get the increments. And now we find the x values between the vertical asymptotes by adding the increments of pi over 4 as follows. Start with x1 equals to 0. So x2 is x1 plus pi over 4. And then it becomes x1 is 0, so it becomes 0 plus pi over 4 is pi over 4. Now to get to x3, add pi over 4 into x2, which is pi over 4 plus pi over 4, which becomes pi over 2. Now find the x4, which will be x3 plus pi over 4, and x3 is pi over 2, so it's pi over 4. So this becomes, if you multiply 2 here and 2 here, it becomes 2 pi over 4, which becomes 3 pi over 4. To get the last points, add pi over 4 into x4, which is 3 pi over 4, so it becomes 4 pi over 4, which is pi. So now set the table. So let's see, write all the x values. The first is 0, pi over 4, pi over 2, 3 pi over 4, and pi. Now we find the y value. So cotangent, this is the vertical asymptote because cotangent 0 is undefined. And the cotangent pi is also undefined. So there is a vertical asymptote here and vertical asymptote here. Cotangent pi over 4 is 1, cotangent pi over 2 is 0, and cotangent 3 pi over 4 is negative 1. So now draw the vertical asymptotes at x equals to 0 and x equals to pi. So this is the vertical asymptote at x equals to 0. This is the vertical asymptote at x equals to pi. And this is vertical asymptote at x equals to 2 pi. And this is the vertical asymptote at minus pi. So then we plot the points pi over 4 and 1. So this is pi over 4 and that's 1. And then pi over 2 is 0. And then 3 pi over 4 negative 1. And this is vertical asymptote. And now we connect these points and draw this and make this curve parallel to this vertical asymptote and this parallel to this vertical asymptote. Extend the graph one cycle to the right of this, one cycle to the left. So how to do this? Well, the period of this is pi. So you go pi units this side and draw a vertical asymptote. And then pi units this side and draw a vertical asymptote. And then draw the curve similar to this one at the center, which is 3 pi over 2. And then draw another curve at the center, negative pi over 2. And that's the graph of cotangent x for 3 cycles. Here is an example 3. A plane flying at an altitude of 7 miles above a radar antenna passes directly over the radar. So here is the radar, and that's the plane flying over this one. Let d be the distance from the antenna to the point directly under the plane. So that's d. And let x the angle of elevation to the plane. So this line makes an angle of elevation x with this horizontal d. So we're going to write d as a function of x. So we try to relate 7, d and x. D is unknown, so we can use d, take the ratio of d and 7. D over 7 is equal to, now d is adjacent and 7 is opposite. And we know adjacent over opposite is cotangent of the angle. The angle is x. So now we to isolate d, multiply 7 here and 7 here. So this will give d equals 7 cotangent x. Okay, so graphs of cosecant x. The graph of cosecant x has the following properties. Because remember, cosecant x is the reciprocal of sine x, and the period of sine is sine x to x. So the cosecant x has the same period, 2 pi. And sine is odd function, so the cosecant is also odd, which means the cosecant of negative x equals to negative of cosecant x. Cosecant 0 is undefined because the sine 0 is what? 0. So cosecant 0 is undefined. Vertical asymptotes at an integral multiples of pi. So the vertical asymptotes are at 0, pi, 2 pi, 3 pi, 4 pi, negative 2 pi, negative 3 pi, and so on. And domain is all real numbers except the integral multiple of pi. So in other words, x cannot be negative, n pi, where n is an integer. And these are the vertical asymptotes. What is the range? Well, range is negative infinity to -1 and 1 to infinity. How to graph the cosecant function? Well, first we graph the reciprocal of cosecant, the graph the sine function. Then draw the vertical asymptote at points where the sine curve passes through x-axis. Then use the vertical asymptote as a guide and draw the cosecant graph. So here is example 4. We're going to graph y equal to 4 cosecant x for one cycle. So in order to do that, first we're going to graph 4 sine x for one cycle. So here is we can choose x 0, pi over 2, pi, 3 pi over 2, and 2 pi. How I chose this values? Well, the period of sine x is 2 pi. So I divided 2 pi by 4, it gives me pi over 2. So I started with a 0 and then added pi over 2. And I got 2 pi, so this is for one period. So now I substitute 0 into sine with the axis, it becomes 4 sine 0, which is 0. And then I plug pi over 2 with the axis, it becomes 4 sine pi over 2, sine pi over 2 is 1, so it'll be 4, and then 4 sine pi is 0, and then I 3 pi over 2, so it'll be 4 sine 3 pi over 2 is 4 times negative 1, which is negative 4, and then 4 sine 2 pi, and sine of 2 pi is 0, so it's 0. So now we have 0.00, 2 pi over 2 and 4, pi and 0, 3 pi over 2 and negative 4, and 2 pi and 0. So I plotted 0, 0 here, and this is pi over 2 and 4, this is pi and 0, and this is 3 pi over 2, and this is 2 pi and 0. So I then connected this, joined this points to this curve. So that's the graph of 4 sine x. Step 2. Draw vertical asymptotes at points where sine graph passes x-axis, like there's a vertical asymptote at 0, vertical asymptote at pi, vertical asymptote at 2 pi. So this is the vertical asymptote. Draw the vertical asymptote here, draw the vertical asymptote here. Then from starting 4, draw the like a parabola, like a cosecant graph. Similarly, from here, -4, draw this one, a cosecant graph. The graphs of secant function. Secant x has the following properties. Just like cosine has a period of 2 pi, secant is the reciprocal of cosine, so the period of secant is also 2 pi. Cosine is the only even function and secant is the reciprocal of cosine, so the secant is also even, which means secant of negative x is secant x. As secant pi over 2, cosine pi over 2 0, so secant pi over 2 is work undefined. This is symmetric about y-axis and vertical asymptotes are n pi plus pi over 2. So the first vertical asymptote is at pi over 2. So wherever is the cosecant is 0, and that's where the you have the vertical asymptote. Domain is x not equal to n pi plus pi over 2. And the range is negative infinity to negative 1 and 1 to infinity. How we graph the secant one? First graph the reciprocal of secant, which means graph the cosine, and then draw the vertical asymptotes at the points where the cosine curve passes x-axis, and then use the vertical asymptote as guide, draw the secant graph. Example 5. So let's graph y equals to -1/5 secant 2 pi x. So step 1, we graph y equals to -1/5 cosine 2 pi x, which is the reciprocal of secant 2 pi x. We can change 1/5 to 0.2. So we're going to graph -0.2 cosine 2 pi x. From 2 pi x, 0 to 2 pi x equals to 2 pi. Now we solve this equation for x. So this will be x equal to 0, and from this equation you get x equals to 1. So we're going to graph this from 0 to 1. So we find the period. Period is you subtract low value from the higher value. So 1 minus 0 is 1. Now we divide this period by 4 to determine the increments. So we can use this 1/4 as an increment and we build a table. So here it's a table for y equal to -0.2 cosine 2x over this interval 0 to 1. So the first row we can put the x value. So we start with the 0, and when we add the increment 1/4, so it becomes 1/4. And then we add 1/4 into previous 1/4, it becomes 1/2. And then we add 1/4 to 1/2, becomes 3/4. And if you add 1/4 to 3/4, it becomes 1. So you're starting 0 to 1, and these are the 3 additional points. So now we substitute x 0 in this equation, y equal to -0.2 cosine 2 pi x. So this becomes -0.2. Now we put -1/4 with the axis, you get -0.2 cosine 2 pi times 1/4, simplify to minus 0.2 cosine pi over 2, and cosine pi over 2 is 0, so this becomes 0. Now we substitute 1/2 in this equation, and this becomes -0.2 cosine 2 pi times 1/2. Simplify, it gives you minus 0.2 cosine pi, and cosine pi is -1 to negative become positive, so it becomes 0.2. Now we substitute 3/4 in this equation and we get negative 0.2 cosine 2 pi times 3/4 simplified to, it gives you negative 0.2 cosine 3 pi over 2. And cosine 3 pi over 2 is also 0. So the final result is 0 here. Now we substitute 1 in this equation, you get minus 0.2 cosine 2 pi times 1. So you have a negative 0.2 cosine 2 pi and cosine 2 pi is 1. So 1 times negative 0.2 is negative 0.2. So now we have these points. You can write this as points. The first point 0, comma negative 0.2. Second point 1/4, comma 0. Third point is 1/2, comma 0.2. Fourth point is 3/4, comma 0. And the last is 1, comma negative 0.2. Now we're going to plot these points in xy plane. And we get this graph. So this point is when x is 0 and y is what? Negative 1. So we get this graph. So this plot is for one cycle. Now we extend this plot 2 cycles to the left and 2 cycles to the right. So and then we get this new graph. Now we draw the vertical asymptotes at the point where the graph crosses x-axis, like here, this point, this one, and so on. So now we have a asymptotes, vertical asymptote. Now we're going to use this vertical asymptote as a guides, and we can draw the parabolas. Like for example, this point it will go like this one. At this point, I'm going to go like this one, and so on, and we get. So here we have now find the graph of y equals to negative 1 over 5 secant 2 pi x.